Proper testing of concrete before and after construction is an important aspect of performance-based durability design of concrete structures. In South Africa, a suite of 3 tests is used. These are the oxygen permeability, the water sorptivity, and the chloride conductivity tests. Each test gives us a durability index parameter. Each durability parameter is linked to a transport mechanism relevant to a particular deterioration process. The performance-based durability design approach links these durability index parameters to service life prediction models and performance specifications. This video presents a demonstration of the chloride conductivity test. The specimens used in these tests are circular concrete discs prepared by coring and cutting of concrete cubes in the laboratory or by taking cores from concrete elements on site. The specimens are typically concrete discs which are 70 mm in diameter and 30 mm in thickness. The disc specimens are dried in an oven at 50 degrees centigrade for at least 7 days, but not more than 8 days. Sample preparation is not covered in this video, and you are encouraged to read the relevant literature on this. The chloride conductivity test involves measuring the resistance of a concrete to penetration by chloride ions. For this test, you will need the following: a 2-cell conduction rig, a direct current power supply unit, an ammeter, and a voltmeter. Before starting the test, the discs are vacuum saturated in a 5 molar sodium chloride solution. The 5 molar sodium chloride solution is prepared by dissolving sodium chloride crystals in water. The mixing proportions are given in the testing manual. The saturated concrete disc is placed in the conduction rig as shown here. The conduction rig comprises of 3 compartments. The first compartment is the anode compartment, which is filled with sodium chloride solution. The second compartment is the cathode compartment, which is also filled with sodium chloride solution. The third is the central compartment where the disc is placed. Once the disc is placed in the collar in the central compartment, the rig is assembled as shown here. The anode and cathode compartments are then filled with sodium chloride solution. Ensure that the power supply unit, the ammeter, the voltmeter, and the test rig are correctly connected using electrical cables. Turn on the power supply unit, the ammeter, and the voltmeter. Slowly turn the voltage knob on the power supply unit to increase the voltage across the specimen in the rig. The amount of voltage across the specimen in the rig is monitored on the voltmeter. When the voltage reading on the voltmeter is about 10 volts, quickly record the corresponding current reading on the ammeter. It is important to note that the recording of the voltage and corresponding current readings should be done in less than 10 seconds after the power supply unit is switched on.